We'll begin today with a little graphing review of a complex number here. So we've got a complex number right here, and before we were plotting them on a rectangular coordinate system here where we had x, y, right? And so we're going to relabel this axis here as j, and normally we were having numbers come in as x, y. Well, when they come in here, this is our x-axis, and then this is our j-axis. So it's plotting this is going to be x5, 1, 2, 3, x5, 1, 2, 3, 4, 5, and then j minus 4, 1, 2, 3, 4. So it's going to put us down here somewhere. Okay, so our coordinates are 5, negative 4. And so if we wanted to break this all down and get our angles and everything like that, once again, we're going to recognize that this length is 4 and this length is 5. So we're going to use our trig, so, ka, toa. And what we want to do is we want to get this angle right here, okay? So what we have is, if this is our angle, we have the opposite and the adjacent. So opposite and adjacent, we're looking at tan. So tan of the angle is equal to the opposite over the adjacent, which is equal to 4 over 5. But we want the angle, so we're going to take the negative 1 of that. So if I went 4 divided by 5 equals, and I take the inverse tan, I get 38.66 degrees. And that's what this is right here. Okay, so we could consider this a couple of different ways. If we're starting and we want to graph this as polar right here, we would be coming down here, the negative 38.66 degrees, okay? So it's going to be negative 38, here's negative 30, so it would be coming through here somewhere, all right? Or if we wanted to start from 0 and came around here, well, what we would do is we would take 360 degrees minus 38.66, and so I would 360 minus 38.66, I get 321.34 degrees. Okay, so from this right here, if we were to come around, this way, we're looking at 321.34 degrees. So that's what we're looking at polar, 321.34 degrees. It's going to be on this line somewhere. How far out? Well, we need to figure out how long this one is. So we're going to use Pythagoras' theorem, realizing that this is c. C squared is going to be equal to a squared plus b squared. So c squared is going to be equal to 5 squared plus 4 squared. And then we need to take the square root of each side in order to get to c by itself. C is the square root of 5 squared plus 4 squared. And so if I were to do that, I know that this is 25 and this is 16. So 25 plus 16 is 41. So we're talking about the square root of 41. And if I take the square root, I get 6.40. So this side right here is 6.40. So if I plotted it here, we would be going 1, 2, 3, 4, 5, 6, and maybe a half. So right about in here. And that point would be at 6 point, this distance would be at 6 point, what was it again? 40. So we would go on 6.40 at an angle of 321 degrees. That's our polar, and this is what it looks like plotted on our rectangular.